Hey everyone, in this video let's take a look at question 55, jump game on Leetcode. This is part of our blind 75 list of questions, so let's begin. In this question, you're given an integer array nums. You're positioned at the array's first index, and each element in the array represents your maximum jump length at that position. We want to return true if you can reach the last index, or false otherwise. Okay, so let's take a look at the examples that we have here to understand how we might be able to do this question. Okay, so it looks like here, we're obviously positioned over here. Okay, we're positioned over here. Let me just call it X, for example. And so what can we do? Well, we can jump one step from index 0 to index 1. Okay, so now we're here. Then we can jump 3 steps to the last index. Okay, so now we're actually at the last index. Over here, if you think about it, we're positioned over here. It says false, you will always arrive at index 3 no matter what. Its maximum jump length is 0, which makes it impossible for you to reach the last index. Okay, so let's see how that's the case. Well, from this index, I have 3 choices, right? I can either jump 1 position, 2 positions, or 3 positions. If I jump 3 positions, then automatically I'm over here, so let's not do that. How about we jump 1 position? Okay, if I jump 1 position, now I can jump 1 position or 2 positions. Let's say I jump 2 positions. Well, I can't do that because then I'm at 0. So now I can jump 1 position. Okay, so now I'm over here, and from here I can only jump 1 position. So I'm back at the X over here where we're at 0. So obviously it can't happen again. And similarly, in this case, we considered where we initially jumped 1 position. But obviously here, if we jump 2 positions and then 1, again, we'll arrive at the X. Okay, so let's take a look at how we might be able to do this problem. And what it kind of looks like to me is like, let's go ahead and draw a graph or something in which we can figure out like what exactly is happening here, right? So let's see. I'm going to let me maybe make this bigger. So I'll remove this. I'll go ahead and paste this. I'll make this bigger. Let's do maybe like a little bit bigger than that. Okay, so let's say we're over here, right? So at the start position, we're going to be right over here. We're going to be right over here. Now, from this index over here, from this first index over here, we have a couple of choices, right? We can either go here or we could go here, right? So if you think about it, the maximum distance we can jump is from, let me maybe just match this as index 0, index 1, index 2, index 3, and index 4. From index 0, the maximum we can jump is to index 2. Okay, so maybe now if I'm at index 1, what can I do? Well, at index 1, the maximum I can jump is again 1 element to index 2. I can jump 2 elements or 2 like steps to index 3, or I can jump 3 to index 4. So notice that, right? Like, what are we doing? We're counting like which indices we can jump to. Okay, maybe let's move forward. Now, from this index, I can only jump maximum to this one here. From here, I can only jump a maximum to this one here. So you can see here that we actually arrive at the 4th index. And you might notice something, right? Like, if I go all the way back here, when we're initially considering the 2 here, I can consider that I can jump the maximum of this index, of maximum of index 1, right? So if you think about it, like max jump is index 1, right? Or not index 1, I guess index 2 is the value 1 here. Now, when I consider 3, the maximum jump I can do is, first of all, I can go here, sure. Now I can go here, and then I can also go here. So if you think about it, my max jump now transforms from not to 2, not index 2, but actually it goes to index 4, right? My maximum goes to index 4. If you think about it, what are we doing here? Well, while we're going along the array, we're basically calculating the maximum I can jump along the certain index. Now, let's say our values were a little different. Like, let's say, for example, here, maybe we had 2, 3, and then 0, 1, and then 4. What about now? Well, if you think about it now, what happens? We start off here, right? And the maximum we can jump is either to here and either to here, right? Now, let's say, what is our max jump at this time? Our max jump here is index 2, right? Which is this 0 over here. So let me just mark the indices, 0, 1, 2, 4. So these are the indices. Now, if I go directly to index 2, right? What is the maximum jump I can do? Well, I can't really do anything, right? I will just stay over here because it's a 0 jump, so I will stay over here. But luckily, we don't have to go directly to index 2. We can go to index 1, and then we can see from index 1, we can actually jump here, we can jump here, and we can jump here. So if you think about it, if any time our maximum jump, it is either exceeding the last value or equals the last index, then I know that I'm able to reach the end, right? For example, even if this was a 4, even if this was a 4 here, we could still, our maximum jump would be like out of the array here, but we could still arrive at the last element here if we wanted. So kind of using that approach, you kind of realize this is simply just a greedy type algorithm in which we go through it and we calculate greedily like what is our next maximum jump. And then if we ever come across a scenario in which our maximum jump is greater than the last element, well, then we are arrived at our solution. So let's go ahead and see how we can maybe write the code for this one. So let's see. So first of all, we don't have to consider if nums is empty, so we can go ahead and skip that. But what can we do? Well, let's just maybe say like last index is equal to nums, I guess length of nums minus 1, right? That would be the last index. And so what am I doing here? Well, I want to keep track of my maximum jump, which is initially just 0, right? And then I will go through my array, which I will be at 0 to length of nums, right? And so what is the first thing I can do? Well, I can see if somehow I can extend my maximum jump. Initially, it's just empty, right? But otherwise, let me see if somehow I can extend my jump to, to maybe extend it and see like the furthest I can reach. So how can I do that? Well, in order for me to extend my jump, if I go back here, in order for me to extend my jump, let me go ahead and go all the way here. So let's say we're over here, right? Initially, max jump will be 0, right? And then when I'm at the 2 here, what I can understand from this is my jump can either be location 1 or location 2. So basically, I can increase my jump by 2 positions here. Okay, so if that's the case, then my maximum jump here becomes 2. All right, so now let me move on to this location here. Now, if I'm at this location here, what is my jump going to be? Well, my jump can be here, here, or here, right? But notice, in order for me to even jump to this last position here, my maximum jump must have already crossed or been at this index, right? Because if I can never reach this index in the first place, then it doesn't make sense for me to even jump from it, right? So if I'm putting that in code, what that kind of looks like is I have to check if what? Well, if I, right, like I is my current index, if I is greater or equal to my maximum jump, right? If this is equal to my maximum jump or greater than it, only then can I consider it. Because for example, if I go back here, let's say we had something like this. Let's say maybe there was a 0 here and there was a 3 over here. Okay, so what happens now? Well, in the first case, right? And maybe let's actually make this one here. Let's change this one. Let's change this one to the number 1. Okay, so what happens here? Well, initially, my maximum jump is 0, and then my condition passes, and so my maximum jump updates to 1, right? And so now I'm basically past this element here, so now I'm considering this one. Okay, I'm at this one here. Now, let me actually even suppose that so we're at the 0, right? So if we're at the 0, we can't really like perform any jumping. So let me just kind of move forward, even though like we won't consider our condition, but even though our condition is false here, actually no, our condition is not false, right? Because if you think about a maximum jump, so I can still arrive at like this one element here. But let's just kind of move forward, right? Let's just move to this 3 over here. Technically, from this position, I should be able to jump here, and outside. But if you think about it, I cannot even reach this position in the first place because my maximum jump is only to this position over here. I cannot reach position 2. So if that's the case, then I can't even consider this in the first place. So that's why we have the check here, to check if the maximum jump is at least the index I or it's greater than it. If that is the case, then I can update my maximum jump to be the maximum of the maximum jump, or it would be what? It would be the current index, right? Current index plus nums at I. So what this would look like, it would be the current index, which is 2, plus nums at I, so 3. So which means in this case, I can jump to a maximum index of 5. And so that's what we're checking here. And now at any point, if max jump is greater than or equal to last index, then I can return true. I don't have to go through the rest of the loop. Otherwise, I can go ahead and I can return false. So that is what we're doing here. We basically have to make sure that the position we're on can at least be reached by the maximum jump. If it can't be even reached, we can't go ahead and add on to it. Okay, so silly mistake. Basically here, the condition is wrong. It should be like this. Or I think I can write it another way. Basically, the maximum jump should be greater than or equal to maximum jump should be greater than or equal to I. I had the condition the other way around accidentally. But basically, after we do this, then we should arrive at the answer. And maximum jump, I don't know why I removed it here. Max jump, basically. Okay, so that should be the solution. Okay, so what is the time here? Well, we're just going through the array once, so it's O of n, and space is pretty much constant here. So that is the solution.